Good evening to everyone. Today in this class, we'll discuss about CAD/CAM Unit 3, which is numerical control. In numerical control, previous class we will discuss about different types of NC controllers. Okay, coming to NC controllers, we will discuss about what is NC and different types of NCs: direct numerical control and computer numerical control. Today in this class, we will discuss about classification of numerical controls and NC modes. Next, dimensioning system, which is in two classifications. One is absolute dimensioning system and second incremental dimensioning system. Okay. I'm sharing my PPT to you. Okay. Today the presentation on CAD/CAM subject, which is for mechanical engineers final years. In CAD/CAM subject, we are continuing on third unit, which is numerical control. In the previous class, we discussed about definition of numerical control, next procedure of numerical control, and what is the procedure we are following to complete a process report by using numerical controls. We discussed in previous class, and components of NC machines. Next, what is MCU and what is machine tool, and different types of machine control units, coordinate systems, and basic requirements. Types of NCs. One is direct numerical control and another one is conventional numerical control. Normally NC, numerical control. These are all the topics we covered in last class, and advantages, next cost and benefits. Up to now we are discussed in previous class. Coming today, we are discussing about classification of numerical control. First of all, what are the classifications included in numerical control? Point one is motion control. Motion control, that is, motion control is nothing but NC modes. NC modes, it is in syllabus. Motion control is nothing but NC modes. What are the modes included in numerical control? Those are point to point and continuous or contouring. Okay, discuss it in later. Next, control loops, open loop and closed loop. Next, what are the power drives we are using in numerical control? Those are hydraulic, electric and pneumatic. Next, coming to positioning systems, we are following two positioning systems in this numerical control: Coming to first one, absolute positioning, and second one is the incremental positioning. Okay, hardware and software. Hardware is NC and software, coming to software, CNC, computer numerical control. Okay, coming to first one, motion control. Okay, in motion control, here I'm showing a figure to you. This is the motion control. First one, point to point control. Okay, here I'm showing a spindle here. The best example for motion control based on first one, point to point moving, is the drilling operation. Okay, the best example is for point to point control is drilling operation. Here I'm showing a spindle here. The spindle, that means the spindle moves from point A to point B, then it is moving from B to C, after then C to D, next E. This is the working, the starting point is A, then work path will be A, B, C, D, E. That is the work path. Here the spindle or machine table moving from point to point. Okay, based on points, the spindle or machine table moves from one point to another point. That is the point to point control. The best example is drilling operation. Moving at a maximum rate of from point to point. That means A to B, B to C, C to D, D to E. It is the moving path. In this slide, we are discussing about the point to point control in numerical control. In previous slide, we are discussing about the point to point control. In this slide also, we are discussing the tool path and tool starting point. Okay, here the first of all, tool starting point will be in this direction, right side direction. Point 1 is the tool starting. After then 1 to 2, that means 1 is the starting point. After then that drill bit or the drill spindle, drilling spindle or drill bit moving from 1 to 2, that means point 1 to point 2. After then the tool moves from 2 to 3. Here the points will be 1, 2, 3. The tool path will be in this direction, 1, 2, 3. Okay, first of all we are taking one work part here. After then, when you want to drill a hole on the work part based on our requirement, then we are taking the starting point and ending point. After then we are making a tool path here. Then following tool path will making a drill on required work part. It is the point to point control procedure. Next, continuous or contouring control. Continuous is nothing but without any breaks, or contouring is nothing but it is not in flat direction or linear direction. It includes some direction, that means some angle or curvy shapes. Here in this, in point to point control, the machine tool or the machine table or spindle moves from one point to another point. Coming to continuous or contouring control, here we want to control 2 or more axes simultaneously to get desired shape. That means here in the below figure I'm showing the contouring shape. That means the highlighted part will be contouring. First of all, the flatted surface I'm showing here, then it will be contoured. Contoured means curvy nature. Curvy nature will be contouring shape to get desired shape. Then here we are using linear or circular interpolators. First one will be the linear interpolator, after then circular interpolator. For flat surfaces, I am using linear interpolator here. Then after curvy natures, I am using circular interpolators here. In this continuous control, the tool contacts the workpiece. Okay, it is about continuous control. Similar to point control, here also I am showing the procedure for contouring or continuous control. The tool starting point will be in this direction from below. I'm starting the point here. Then based on flat surface, I'm using linear interpolator. After then, for requirement based on curvy nature, I'm using circular interpolator here. The tool profile will be based on circulars here. Then tool path will be based on the points. That means based on the circular shapes. It is the continuous or contouring control. Then interpolation methods. Interpolation method, coming to interpolation methods, here we are discussing about different types of interpolations. Already you will know about what is interpolation. Interpolation means interpolating a line between 2 points. That means it is nothing but linear interpolation. Interpolation is nothing but based on 2 points, we are interpolating a line between 2 points in a space. Coming to circular interpolation, circular interpolation is nothing but here we are taking starting point and ending point, and middle point will be center of radius. It is the circular interpolation. Next, helical is the combination of circular and linear motions. Next, parabolic and cubic interpolations. Free-form curves, that means Bezier curves, okay, B-spline curves, those are formed by using parabolic and cubic interpolation methods. Next, coming to control loops, it is the classification in NC, numerical control. Second one is the in control loop. Two classifications are there. One is open loop and second one is the closed loop. Open loop, here the pulses coming from controllers, then pulses will be given to motor. Motor is driven by using electric power. Then it is given to table, machine table. Here no position feedback will be given in open loop. Here we are using motor is stepping motor or stepped motor. It is the open type, open loop type. Coming to closed loop type, we are using DAC amplifiers, up to down counters, DC motors and tachometer encoders. Coming to closed loop controller, I am showing the procedure. First of all, the pulses will be given to DAC. DAC is nothing but differential amplifier controls or direct amplifier controls. It will be given to amplifier. Next, coming to differential amplifier, it will have one positive terminal and one negative terminal. One positive and one negative terminals. Next, it passes to DC motor, then tachometer, next encoders. Okay, in closed loop, compared to open loop, in open loop no feedback will be given. In closed loop, feedback will be given. In this, tachometer is used for measuring the speed of RPM, speed of shafts in RPMs. It is the closed loop control mechanisms. It is the inner loop mechanisms. One is open type and closed type. Negative, in this, positive terminal given to DC motor and negative terminal is given to tachometer. Tachometer is used for measuring speed of shafts, rotating shafts in RPMs. DC motor will be used to drive the spindle or drive the table, machine table. It is the closed loop type. It is the main schematic diagram of closed loop control. First one, controller. Controller will give commands to controller. After then, it will be translated or transformed to servo drive. Servo drive is nothing but it will have drivers here, nothing but it is a gearbox. It consists of controller gives the commands to servo drive. Servo drive moves the motor. Okay. First of all, we are giving commands using of NC numerical controls, NC codes. NC codes will be given to controller, then it transforms or translates into servo drive. Servo drive is used to drive the motor. After then it connects to tachometer used for measuring speed of shafts or speed of gearbox in rotating position. Tachometer is connected to gearbox. Machine table is moving or rotating, not rotating, moving from left to right and right to left. Okay. After that, position transducer. It is the closed loop control type. Why we are preferring closed loop control? It is used to measure the displacement of table. Displacement is nothing but motion, the direction moving from left to right or right to left. The advantage of closed loop is nothing but positioning is very accuracy compared to open loop control system. In closed loop control system, the positioning is very accurate. Okay. Next, coming to third classification, power drives. In power drives, three classifications are there. One is electric motor, second one is hydraulic drive, third one is pneumatic drive. First one, electric motor. Electric motors are widely used. Why? Because it is in small sizes, okay, ease of control, low cost. Supply is power supply in electric motors. Coming to hydraulic type, compared to electric motor, hydraulic drives are very much larger sizes. Okay, larger sizes, very power requirement is there. Size ratio is compared to electric motor, it is 1/3 of electric motor. To hydraulic drive. Next, pneumatic drive. Pneumatic drives are rarely used in NC positioning system. Compared with electric motor and hydraulic, we are using pneumatic drives for auxiliary devices, not for using all operations. We are using mostly electric or either electric motors or hydraulic drives for power drives. Next, positioning system. Based on positioning system, two classifications are there. One is incremental positioning and second one is the absolute positioning system. First of all, I'm showing the difference between what is absolute positioning system and what is incremental positioning system. That is, positioning is nothing but dimensioning system, and what is absolute and what is incremental. Here I'm showing, first of all, I'm taking a work part here. The machine spindle or machine table moves from one point, starting point to ending point. First of all, I'm discussing absolute positioning. Absolute is nothing but direct positioning or direct movement or direct translation from starting point to ending point. In this, absolute positioning means the machine tool or machine table moves from 0 to, from origin 0 to 40. In absolute positioning system, the machine tool or machine spindle moves from origin 0 to 40. In x direction, the spindle moves from 0 to 40, x is 40. Then after it translates or moves from x direction 40, then in y direction 50. It is the absolute positioning system. Then what is incremental positioning? What is the difference between absolute to incremental? Okay. Coming to incremental positioning, in absolute positioning, we are taking direct positions or direct movings and direct translations. What is the x direction and what is the y direction? What is the length or what is the distance, the work part. In the work part, the machine table or machine spindle moves from origin to required point. Coming to incremental positioning, we are taking not direct positioning systems. Based on incremental positioning, we are taking the difference. Okay, first of all, the machine tool moves on the workpiece 40 in the x direction, then 50 in the y direction. It is absolute. Coming to incremental positioning, the distance will be, starting point will be 20, 20, then it moves to 40. Okay, 20, 20, after then 40. The difference will be 20. It is the direction of x. X 20, 20. Then in y direction, similar to x direction, y direction also, difference will be moving from 20 to 50. Okay, students, observe the difference between absolute to incremental positioning. In absolute positioning, we are taking direct dimensioning system. That means what is the tool traveling distance? That means what is the machine tool traveling distance? From 20, it moves from 40. We are not taking starting points. That means what is the distance traveling by the machine tool from origin? Here in x direction 40 direct, in y direction 50. It is the absolute. Coming to incremental, only the confusion between absolute to incremental is nothing but absolute is direct dimensioning or direct positioning system. In incremental, we are taking the difference from starting point to ending point. From starting point to 40, the difference will be 20 to 40. 20 to 40, the difference will be 20. After then, in y direction, it will be translated or transformed to 20 to 50. The basic difference will be 30. It is the incremental positioning. 20, 30 is incremental positioning. Then 40, 50 is the absolute positioning system. Then an NC machine rating. Rating is nothing but reviewing, or based on rating, we are preparing NC machines here. By following NC machines, the accuracy will be very correct. Accuracy is nothing but dimensioning. Okay, dimensioning, next properties, all are accurate. Repeatability is nothing but wastage is very less. By using, for example, we are taking manual labor. Based on errors, the wastage capabilities or wastage performances are very high. Compared to manual labor, based on NC machines, the wastage is very less. Spindle and axis motor horsepower, number of controlled axes, dimension of workpiece. Those are the ratings of NC machines. The main characters or main ratings of NC machines are accuracy and repeatability. Then NC accuracy. Accuracy is nothing but contribution, and hardware means MC. Coming to software, CNC. Control resolution. Control resolution is nothing but the minimum length distinguishable by the control unit, basic length unit. Okay. Hardware inaccuracies. Inaccuracies is nothing but errors, tolerances, machine operations, thermal errors. Coming to first one, component tolerances. Tolerances is nothing but, first of all, we want to produce a part. First of all, we are giving a tolerance or allowance to the required part. Based on shrinkages, allowances, we are giving some tolerance, plus or minus 0.02 or 0.02 or 0.2. Inaccuracies in the machine elements, machine tool assemblies, errors, spindle runout leads to backlash. Those are the component tolerances will be given in first producing of parts in NC. Next, machine operations. Tool deflection produces dimensional error. Okay, in the machining operation, dimensional errors are there and charter marks on the finished parts. Those are the inaccuracies in hardware. Next, thermal errors. Thermal means heat. Heat generated by the motor operation, cutting processes, friction on the ways and bearings, etc. By using cutting fluids and drive motors away the center of machine and reducing the friction. Okay, we already know about that. To reduce the heat by using of cooling fluid, cooling oils or cutting fluids to reduce the friction between tool to the work part. Okay, to reduce or avoid thermal errors. Next, repeatability. Repeatability in the wastage errors. To avoid wastage errors, average, that means to reducing average errors. It is the repeatability. Lead screws. Lead screws, converting the rotational motion of the motors to a linear motion. Pitch is nothing but distance between adjacent screw threads. Okay, here I am showing the difference between adjacent screws in direction right side and left side. It is the difference. That one is defined by pitch P. The number of teeth per inch n equal to 1 by P. Basic length unit is P by N, capital N. Okay, example, one problem here. A machine has one basic length unit 0.001 inches to move the table 5 inches on x-axis at a speed rate of input per minute, input per minute. Calculate pulse rate and pulse count. The formula for calculate pulse rate is speed by BLU. In previous slide, we discussed about BLU. Basic length unit is pitch by N. Numbers. Speed by BLU. Speed is 6 by BLU is 0.1. Pulse rate is 6,000 pulse per minute. And what is pulse count? The formula for pulse count is distance by BLU. This is the difference between pulse rate to pulse rate is speed by BLU. When it comes to pulse count, it is transformed to distance by BLU. Distance is to move the table 5 inches on x-axis. Okay, distance will be 5 and BLU is 0.001. Then 5,000 pulses. It is the pulse count.